Hello everyone. In this video we're going to go over the three functions print, empty, and search for our stack class. So first we're going to start with print. And with print, well, since we're just going to be printing to the terminal, we're not going to return anything. So I'll say void print, and because our stack contains a dynamically allocated array, we're going to be printing it like it would be an array. In the usual case of printing a dynamically allocated array. So first, I should create a size t called size. We'll call our size function, so we'll have a variable as a size, and we don't have to continuously call our function over and over and over again. And we're going to start from 0 because our offset for the array starts at 0 because the arrays start at 0. And we're going to continue while I is less than size. And we're going to increment by 1. And if you don't remember correctly, the notes on intermediate pointers shows how we can go about printing dynamically allocated arrays. And this is the way to do it. So we're going to dereference values, and we're going to give it an offset. Right? This will be analogous to doing this, if thinking of it as an array. There we go. If we thought of it as an array. Right, so if this is a static array, we'd print it this way, but since it's a dynamically allocated array, and since we're using pointers, we need to do it this way. We need to dereference our pointer. Right, so what this will do is that it'll start from the beginning of the dynamically allocated array and go to the end. And it'll print out every single value. And every time it does print out every single value, we're going to print a space after it. So that way all the data that we print from the dynamically allocated array is separated by spaces. Finally, we're going to print a new line character so that way we can make it look clean. Right, so that'll be it for the print function. Next, we're going to have our empty function, and we're going to determine the truthness if it's empty or not. So think of it this way, saying the stack is empty. Is the statement true or is the statement false? Right, and this function will determine the truthness of that statement. So how I'm going to check for this is that how do we know that the stack is empty? Well, two conditions need to be met. The fact that values is equal to null and that size is equal to 0. If both of these statements are true, then our stack is empty. That's why it is important for us when we pop to set values to null pointer and size equal to 0. And when we create our default constructor to set size equal to 0 and values equal to null. So that way we know that it's empty. Those are the two conditions in our stack where we say, okay, the stack is empty. So we check for that here, and it was very important that we do that because now we can reliably call this empty function to truly determine if our stack is empty. Seems simple enough. So our last function that we'll cover is going to be our search function. So when we're searching, we're going to determine if it's true that this value is inside of the stack. Right, so since this is a stack that can be ordered in any way, we can't make any assumptions that if it's ordered from less to high, or if we even know that it's in there. We're trying to determine the truthness that a value is inside of our stack. So because of this, we're limited just to a linear search. Because in reality, we just don't know if the values of our stack. We do not know the values of our stack. So it is not safe to assume that it'll be there. So with that assumption in mind, we'll just check every single element if values plus I is equal to our value. Right? We need to check every single element because we don't know what's there. And in that case, we're going to return true if it's equal to the value that we're looking for. In that case, we found it, right? That means that our value that's here is contained somewhere along this array or stack. But we have to check every single value of the stack because we're not going to make any assumptions, right? So in this for loop, we're going to continuously check for that. But what happens if we get to the end? Well, that means there hasn't been a case where value is contained in the stack. So we need to return false. Because the only way to get to the end of this for loop, after this for loop, is that if this is wrong all the time, and if this is wrong all the time, then value is not inside of the stack. This seems simple enough. Now that we've gone through the process. And that'll conclude this video. On the next video, we're going to be talking about overloading the operators. We're going to be talking about overloading the equals operator, the double angle brackets operator for using cout and whatnot, the equals operator to determine if stacks are the same or not, and not equal to determine the reverse of that. Thank you.